Most people, when they are building their portfolio projects, they normally jump straight into the SQL and Power BI. But in real data projects, that's not where things start. Every system that you see, be it a dashboard, be it a report, analytic solution, they normally start with one thing, that is a data model. So in this video, we shall going to build a simple, a mini supermarket system, and also we shall going to explore the 3 levels of data modeling, and we shall going to build this system with the help of a problem statement. So as we are building this system, we shall also going to explore the 3 levels of data modeling. So let's jump straight into it. So here we have a problem statement where a growing supermarket chain operates multiple stores and serves hundreds of customers daily. The business currently records customer purchases information, product information, and payment transaction using spreadsheet and disconnected system. As the volume of data increases, the management is experiencing challenges in tracking the sales performance, monitoring the customer activity, and generating accurate business reports. The supermarket management want to build a centralized data system that can efficiently store and organize information about customers, orders, products, and payment. Before implementing the database, the business need a well-structured data model and that accurately represent its operation and support the future analytics and reporting needs. So as a data analyst stroke business intelligence developer, your task is to design a data model for the supermarket system by progressing through the 3 levels of data modeling. So we have the 3 levels of data modeling, that is conceptual data model, logical data model, physical data model, and then you provide a final solution with a clear blueprint for storing supermarket transactional data and support future reporting and dashboard and business intelligence initiative. So here basically the problem is simply required us to act as a data analyst stroke business intelligence to design our data model with the help of these 3 levels of data modeling. So that is the conceptual, logical data model, and physical data model. So first of all, before we build any data model, first of all, we need to understand these 3 levels of data model. So these 3 levels of data model, first, this is the summary of these 3 levels of data modeling. So we have the conceptual data model. So this is, first of all, we need to understand the business objectives. So this conceptual data model, this one deals with the business concepts. If, for example, we are building a model for supermarket, what are the objects in this business? So in supermarket, it deals with customers, orders, transactional, payments, and so on. So those are the objects of this business. And then you have logical data model. Logical data model is where now we bring the structure. We bring the structure where we shall going to design, we shall going to identify the entities and their respective attributes, and then also identify the primary key and foreign key of each entity. So it's more of like, for example, if for example a customer, it will contain tables like customer. For example, in supermarket, it will contain tables like customer, orders, products, and payment. So that means this will be our entity, and this entity we will treat them as tables, and these tables, they will have columns. This column is what we call attributes, and these tables, they normally relate with one another. So that means we'll have to identify the relationship among these tables. And then in that connection, we identify the primary key and foreign key. After that, now we'll come to the technical implementation. So after we've understood the problem, I mean the business objects, and we've clearly state this business object, their respective columns or attributes, and also we've clearly understand the relationship of these business objects in this logical data model. The final step now is to bring now the technical implementation, where we're going to build a database and then try to define all the attributes or the column of each and every business of this business entity. So let's jump straight by starting with the conceptual data model. So let's conceptual data model. So let's just take this one here. So conceptual data model. So here we are dealing with majorly on business objects here. So what are the business objects here? So business objects here are of this supermarket. We are building a supermarket. Business object stroke entities. So what are just the business model of supermarket? We can see customers normally. Customer buys products, and also orders are made in stores. Orders are made in stores, and then each order contain multiple products. You can see each order might contain multiple products and so on. So these are kind of like the business model of how a supermarket operates, where customer buy products and then orders are made in the stores. Each order may contain multiple products. So it's so we can let's build a relationship of these. How they relation. So we can see customers places orders to orders orders are processed in orders contain products, and then stores process there, stored processes these orders. So you can see these are more of like we are defining the business objects. So these are the business objects where we have customer places orders, orders contain different products, and these orders are processed in the store. So what are our business project? Our business objects. So our business objects here are our business objects here are our first business object here is this customer. Our second entity here is orders. Our third object here is these stores. And our fourth object here is products. So these are our business object of our supermarket business. These are these are our business business entities of our supermarket business. Yeah, so we are done with this our first model, and the second model is now the logical data model. Logical data model. Logical data model. So this is our second level of data modeling. So here now we start structuring the data. We convert the business object into entities and define their attributes. So basically we are converting these objects into entities, and so we are converting this object into tables. So these are we are converting them to entity, converting to entities. Entities basically is the tables. We are converting them to tables and define attributes. Define attributes. Attributes basically are more of like columns. And build the relationship among these, and build relationship. And build relationship where we shall going to define the keys. That is the primary key and and foreign key. Yeah, so first of all, so let's define the attributes of these entities. So we'll start with the customer. So customer, so let's treat customer now as customer table. So customer table can contain what kind of columns. So first of all, this customer table can contain customer ID, column customer ID, customer ID. Also, this table can contain name, customer name, and maybe phone number of the customer. Yeah, so and then the second entity, the second entity is orders. So orders, here we can have things like order ID. The columns, we can have column like order ID, customer ID, we can have things like store ID, we can have things like order date, and so on. After this, we shall also going to define the attributes of stores. Attributes of stores. So we have in store, we can have store ID, we can have so let's just bring this store here. We can have things to do with maybe location, where the store are located. So we are just basically identify the different columns of these different entities. And then the other entity are products, which is so in products we can have product ID, a column product ID, something like this. Also in product we can have product name, also we can have category, also we can have price, the unit price of each product, and so on. So we have basically populated the columns of each and every entity. So these are the entity, and we have populated each and every attributes, their respective attributes. And then the other one, we can also add order item. So this one will have to add order item table. So this one will have order item, let's say ID, and then it can have order ID, it can have product ID, it can have quantity, it can have unit price, and so on. So this order item is normally we introduce it so that we resolve the conflicts of sometimes a single order, so let's say order ID, so let's say order ID 1 can have different products, let's say P1, P1, P2, and let's say P3. So this single order, it has these multiple products. So for us to populate, or for us to, so we need to create a different table that will have these products in their respective row. So for example now, for example now, let's bring a table, let's bring this table. So for example here we shall going to have the so for example here we shall going to have the order ID, and then here we shall going to have the product, and here maybe we are going to have the order item. So this is an example of let's say the order item table. I'm just trying to show you how the order item table is very important. So you see, like this one order ID, it has these different products. So that means we'll have to create another table that will distribute all these products into their respective column. So that means order ID will be simple 1, and then we put product 1, P1 here, and then also the same order ID, but here we put P2, and the same order ID, here we're going to put P3, and here we have order item. So this is more of like we are just ranking to, it's just it's more of like we are saying this as a unique. Each and every row is given a unique order item. So in this column, this one will be more of like a primary key. So you see, this is the importance of coming up with a order item. So now that we have all our entity presented with their respective attributes, now we need to define the relationship among these entities. Relationship. So what are the relationship among these entities? So for example, one customer, so for example, one customer can order many, can place many orders. So can put M and then order. So that means there's a relationship between customer and orders. So one customer can put many order, and then we can also have one store can process many order. Store, so let's say put one, and say this can process many orders. Let's put this one here, orders. And then one order can have multiple order item. So like this one order, it can have multiple order item. So as we can see here, one order ID, it has multiple order item. So that we can write one order one, can have many order item. And also one product also, for example, product P1 can have many order item. So product one product can have many order item. Yes, so we have basically identified the attributes, and we've populated the attribute. We've basically identified the entity, sorry. So we have the entity customer, orders, stores, products, and order item, and we've populated this entity with their respective attributes. So these are the attributes: customer ID, name, order ID, customer ID, and so on, store ID. So these are the attributes, the columns of this entity. And then after that, we have also built the relationship, how these tables or entity, they relate to one another. After that, now is where now we're going to now build the real implementation of this entity into our Postgres SQL. So that means we'll come and create our own database. So you will simply create a database. Let's call it supermarket database. Yeah, so after that, where's the supermarket database? Yeah, so we're simply going to create a database, and then we will going to write all these, and then we're going to now write or create tables for all these entity. So let's start with entity customer. So we're going to write create table, customers. So we're going to have customer ID, so this one is integers. We are defining the data type integers, and then we shall going to identify this as our primary key. Also, so let's just go back to this. So these are the column for this. So yeah, so we'll have here to identify the data type. So this one is int, and then this one we can call it primary key. And then name here we can this one we can give it a we can give it a data type of varchar 100. And then phone number, this one also we can give it a varchar of 100. And so on. So after that we're going to execute it. Varchar 100. So after that, let's execute this. Phone number, okay. Phone number. And then we execute this. Yeah, so we have our first table we've created. So we can confirm by selecting select star from customers. Yeah, so we have our customer table created. And then we can proceed to the next one, which is product. Create table and we call it products. So products, copy, yeah, products. We shall going to give it a data type. Data type is int. This one is also a primary key. And product name, this one also varchar, data type varchar. 100. And then category, same data type. And then price here can be decimal, so let's say decimal data type. Decimal, and so have to specify the number of decimal, and 2. And then we put a so after this, let's execute this. Yeah, so we are done with the products, so we can also confirm it. Execute. Yeah, we have a products table, and then another one can be create store, create table store. So this one, let's also go back to, where's the store ID, to store ID. So this one also, store ID can be integers. This is the primary key. Primary key. Then here we have location. So location, this is varchar. Also, let's put it 100, and so on. So let's execute this. Yeah, let's confirm it. Store. Yes, so we have our store here. Now let's go to the next entity, that is next entity, there's order. Next entity is order, so let's copy these orders attributes. So create table orders, and then we bring the attributes. We also identify this as our primary key, so int primary key, comma, customer ID. This one data type is integers, so just write int. Store ID, so this one is data type is primary key, data type is integer, sorry. And then order date, data type is date. date, and then we shall also going to say in this table customer ID and store ID, these are primary, these are foreign key referenced from. So here we have primary key. Store ID in this table is primary key. So store ID in this table orders will be foreign key. So we'll have to specify. So we're going to write foreign key. Foreign key customer, or we can just leave it that way. We don't have to add the foreign key. So let's create this. Yeah, let's remove this. Yeah, so let's confirm this one. Orders. Yeah, so let's now do the last item, that is order item. So let's copy this. So create table order item, and then we can have the column. So let's start with order item. So this is our primary key. So data type int, it's also a primary key. And then order ID, this is integer, comma, and then we have product here, product ID, this one also is an integer. Quantity, this one is also an integer. And unit price, this one, it can be a decimal. And we can specify the number of decimal, 10 and 2. So I think this one is also okay. Create decimal. What is not happening? Oh, unit price, yes, should be. Yeah, we created this. Yeah, so we have successfully created all our tables. So also let's confirm this. From orders item. Yeah, so we have all our tables. We've created all our tables of our supermarket system. So this one will be now, so this is the layer, this is the level, we call it physical data model, where we have technically implemented all our entities into SQL. So let's have just a summary of what we've learned. So basically we have learned the conceptual data model, where we have tried to understand the business objects. So we've seen that these are the business objects, the customer orders and products. And then so here in this level, we've not introduced any technical details yet. So we are simply trying to understand the business objects. And then we've gone to this logical data model. So the logical data model, we've introduced the entity. The entities now become our tables. So these are entities, and then we have also identified the attributes. So the attributes are our columns. So in each entity, we have identified the columns. So these are our attributes and so on. And then in this also we have created the relationship. That is as you have seen here, we have identified the relationship where one customer can have as many orders as possible. One store can process many orders. So we have simply identified the relationship among our entities. So in this relationship, we normally have the primary key and foreign key. So for example, customer ID, one customer can have as many orders as possible. So that means the customer ID in customers table, that one will be our primary key. So primary key is basically a unique identifier it's a column that contains unique identifiers. So that means in this, for example, in this table, customers, each and every customer has his or her own unique customer ID. So that customer ID will be our primary key, a unique identifier of the customers. And the customer ID, that is referencing the customer ID from this customers table. So for example, in orders table, it will contain customer ID. So this customer ID from this orders table, it references the customer ID from the customers table. So that means this customer ID is what we call now foreign key. The key or the column that references the primary key. So here we have seen the relationship among the attributes, among the entities and so on. And then the last one now, the technical implementation, where we have actually created our database and we have created our tables. We have identified for example, the data type. We have identified the primary key. So here is now more of like they're now bringing the technical details. So we have this is the technical implementation, where we have the actual database tables. We have the data type, indexes and performance design, the SQL and database specific details. So as you have seen here, we have created our database, and then we have populated the business entity or the the entities, the business entity or the tables with their respective column, and we've inserted, for example, relevant data types and so forth. So this is basically the summary of the three levels of data modeling.